Hello everyone. In the previous module we covered modeling and we got this model, and in this module we are now going to tune a fuzzy controller for this model. So the first thing we are going to do is remove this data import block, and we are going to remove the error criteria, and we are going to instead put a fuzzy logic controller block. And we are also going to put a step change here to generate the set point here. For this fuzzy controller block here, the output of this is going to go to the dead zone. We're also going to plot our controller response so we can see what's going on. And just to look at the fuzzy logic controller block here, we're going to make sure our execution interval is the one that we want to run the controller at, which is 50 milliseconds. You can make this a multivariable controller as well, but for this, of course, it's only a single input, single output loop. You can also have auxiliary inputs as well that you can put. In terms of our minimum and maximum controller output, we are going to go 0 to 10. Although over here, because there's a dead zone, we may want to make it, for example, 2. So as not to, because we wouldn't have a need for the controller in an actual process to go below that, but for now we can just leave it at 2 and maybe just give it an initial 0 and give it an initial bias of 2, so you can see how the controller functions. Here you can see these are the default membership functions, and there are also some default rules. Okay. And now we are going to go ahead and set up our optimization constraints, which are going to be 1, a step response, and 2, signal statistics. And I'll explain what these mean in a minute. So for the step response, we're going to have the set point here, and then we are going to have the output of our model here on the other side of the step response. And we're also going to put the step on this plot. And for the signal statistics, we are going to make sure that our fuzzy controller is behaving the way that we would like it for it to behave. Okay. Lastly, of course, we require the feedback from the endpoint of our model back to the fuzzy controller. And now we are ready to set up the tuning. So let's go ahead and configure. And for our design variables, we're no longer trying to tune the dead zone or the transfer function or the limiter, but rather we're trying to tune the fuzzy logic controller. Here we can tune basically everything. We can have fixed or variable membership function range. We're just going to do variable for all of that. We can tune rule actions, rule weights, the various gains. For this, we are going to have the error constraint be the step response, or the optimization constraint be the step response. And here you can see that we can specify maximum overshoot, maximum rise time, maximum settling time, maximum steady state error, oscillations, asymptomatic slope, and so on. So there's a lot of variability to basically be able to get the controller to do exactly what you want. For now, I'm just going to leave these all at 0 just to see what response we might be able to get. For the signal statistics, we're going to have the maximum at 10, we're going to have the minimum at 2, and we're going to have the maximum rate of change at, say, 8. Okay. So we're going to run our simulation now, and this is what it looks like initially. We have the step here at 1. We're going to change it to 9 here. So we're going to have a set point of 9. And this is what our simulation looks like. We have our set point up here. Here we have the model, and here we have the fuzzy logic controller. So let's see, once we run our tuner, what happens. And as you can see here, very rapidly, we have gotten a very, very good response. And it will take just a little bit to smoothen out. Okay, so you can see here, this is a very good response. Very nice, very smooth. Now, what happens, we're going to want to, before we test this fuzzy controller on the actual setup we have, we're going to want to play around and see what's going to happen if, for example, instead of a step of, instead of having it at 9, we make it 1. Is this controller going to be able to control well? It looks okay. Over here, you can see it's, let's remove the initial controller bias that we had here and see what we get. Okay, here we have a fairly decent response. Okay, and all the way at, let's just say in the middle, good response. So it seems no matter where, you know, the value is, of course, we're getting a good response on this controller. Okay, so we're happy with that. The other thing we're going to want to test for is noise. How does the controller respond if there is noise? Now, in order to test that, what we're going to do is we are going to put in a summer here, and we are going to put in Gaussian noise. We're going to add that to the endpoint of our model, which means that we need to now make the endpoint of our model the summer with the Gaussian noise. And here we're going to put, let's say, maybe even that might be too much, but let's just see. So that's going to be a lot of noise. Let's go even smaller than that. Okay, so that's a decent response. Okay, so this looks like a reasonable response to a reasonable amount of noise. So this controller is looking good. It's doing well at all points in the model, and it's responding well with noise. So this looks like it's going to be a decent controller. So why don't we go ahead and save this so that we will be able to just tutorial 1, refer back to it later, and not lose the hard work we've done so far. So the last thing we'll do is we're going to configure the segment file, which I will show you how to do in the next tutorial, and then we will test it on the live system. Thank you.